All right, so this is second module. So this module is about the conditioning processes. So conditioning processes are the secondary and the post-secondary process. So these all are secondary manufacturing processes. So six, but first three are about the actual process, and then later the three are about the post process of the in the secondary process. So this is the first for secondary module. So there is a conditioning processes. So I have four objectives in this module. So first one is describe how heat, mechanical force, or chemical action can be used to condition materials, and regions material are conditioned and why, and the name and describe six common thermal conditioning practices and explaining mechanical conditions and how it occur. So those are keywords. So this is the conditioning process. So conditioning process is changing the external appearance of material and use heat, mechanical force, or chemical actions. So these are three major source of conditioning processes. So they change mechanical properties of material, right? So the considerations in conditioning are in general three. So first one is what are the desired mechanical properties. We need to consider if the material want to have like malleable with ductility or brittle, maybe not brittle, but other processes or other materials we want to have. And then we need to consider its internal structure and then conditioning procedure. So internal structure are related to the conditioning process because each, for example, metal has all different internal structures. So most of metal has metallic bonding, but the depending on its manufacturing process, metal has different crystalline like grain patterns in the inside. So we need to consider its structure, internal structure. So and then if we process in the secondary process, such as rolling, that change its internal structure, right? Like this. They could be in general much more harder than first structure. So we need to consider how are its internal structure. These are material properties. We look at these properties in the week of 2 and 3. So there are seven material properties. First one is physical, mechanical, chemical, thermal, electronical and magnetic, acoustic, and optical. Those are seven properties. So also we can determine or which properties we want to have, such as in physical, what kind of shapes or size or density, porosity. Those are our consideration. And then mechanical properties are strength, stiffness, elasticity, plasticity, hardness, wear resistance, or ductility. So yeah, so those are materials property. So we need to consider those properties in before doing the conditioning processes. And there are many regions, but we want to highlight three main regions for material conditioning. So first one is make material easier to form or separate. This is our first reason. And then remove internal stress that has built up during the casting, forming, separating, and assembling processes. So I want to just draw again one more time. Let's just say this is a metal, and metal has an internal structure, a grain structure. But after like hammering or casting, that could have internal structure, internal stress. That means it looks like fine, but in the internal structure, there could be some stress. it's kind of potential damage or kind of like here in between the structure or inside. There could be stresses. Stress are accumulated in the structure in the internal structure. So that's why sometimes we need to remove each internal stress to make sturdy. Also, third reason is to develop specific mechanical properties, such as make harder or make softer or other properties. So those are three reasons. All right, so there are three types of conditioning. First one is thermal and chemical and mechanical. So, but among the three, in general, the metal products, we use lots of thermal conditioning processes, and I also want to explain more about those three processes in this lecture. All right, so thermal conditioning is important. So it changes internal structure of material to control the heating and cooling. So heating and cooling are the key in the thermal conditioning. So how we heat or how we cool the material. That's the key to change internal structure. So there are certain methods. So first one is hardening. So make harder the surface of material, and softening, make it softer, right? So, but in the softening has two types of softening. So tempering and annealing. So I will further explain about those processes. And then third one is normalizing, that relieves stress in steel and develop the fine uniform grain structure. So among the three, so normalizing is a little bit separate process from the hardening and softening. So it's a kind of softening, but it reform the the initial structure. So with the high temperature, so that is normalizing. And yeah, this is the first one is hardening and tempering process. So because most metal products, after hardening, the tempering is followed. This is a general process. So this bottom graph shows the hardening and tempering process. So it's the simple. So we put the metal and then metal heat using torch, and then after that we put into the clean cool water. That means it increased temperature like this around, it depend on its internal structure or components, but in general like 600 temperature heat, and then suddenly immediately we cool the material, like like this, like putting into the cool water, like changing the temperature immediately, very fast. So during we heating the material, the internal structure is like as the metal is molten, so they change the internal structure, right? And then they immediately cooling, that very rapidly solidify, that makes the material harder, right? That's the hardening. But tempering is the secondary process. So after this, they heat one more time. It's not much hot, so almost 200 Celsius, and then slowly cool, like it slowly solidify by, and after heating, then just putting the material on top of the anvil, and then they cool using the natural air. That is the slow solidifying or slow cooling process. So that make the material softer by cooling slowly. Like slow cooling makes the metal softer, and then rapid cooling makes the metal harder. That's the principle, right? So, and then I'm gonna give you a question. So why in the practice they do these two steps? As I explained, first step is hardening, right? And then second step is tempering. So what if we just stop here? Just we do hardening, right? Heating and then rapidly cooling. What happened? This material could be very fragile and brittle. That in that process, um, that accumulate a lot of stress inside because that was rapidly hardened, right? So that's why we need to stress in the internal structure. So that's why we do one more time tempering. So heat moderately, with moderate temperature, and then slowly cooling. So that makes the material harder, the inside, and then remove the stress. That's the hardening and tempering. All right, so and then annealing process. Annealing is like this. So hardened metal is very stiff, but annealed metal is little bit malleable, right? This is annealing. So annealing is almost similar to tempering, the softening of material, but the annealing metal is heated to specific temperature and then slowly cool. So that's the annealing process. It's separate from hardening and tempering, but annealing is makes the material softer with a different process. But like this. So annealing is heat the material, and then slowly, very slowly, cool. That's the annealing process. It's similar to the tempering, but annealing, the purpose of annealing is to make the material itself the softening. All right, so second is chemical conditioning. Oh, I'm sorry. So I want to go back one more time. So for the thermal conditioning, so there should be one condition that can do thermal conditioning. That is carbon. So the carbon is one of the core elements of ferrous metal. So as I explained, in the metal is like ferrous. So and then we put carbon. So metal ferrous combines with carbon, that cause carbon small um, element. So carbon can be reside between ferrous. So in general, so carbon percentage of carbon is 0.1 to 1.5% of the metal. So for the thermal conditioning, the metal should have certain percentage of carbon because the ferrous itself does not get any stress. So the stress get in the between ferrous and carbon. So that's why we need to the material that has certain percentage of carbon. So that's why in the high percentage of carbon material, that is very good, very work well in the thermal conditioning. In other words, but lower carbon percentage of metal that does not work in the for the thermal conditioning. All right, the next second is chemical conditioning. So in the chemical conditioning, we need catalyst. So catalyst makes the material start the chemical action. So that's catalyst. So there are lots of catalysts in the like such as a plastic manufacturing process. So one example is water. Water is a good catalyster. Also, sometimes we use electricity or sending electron, or we use a specific chemical for the chemical conditioning. And then these, I want to highlight this term. So polymerization, that is linking together chain-like molecule of plastic, the changing it from liquid to solid. This is for example, some monomer. This is ethylene. Ethylene is this is ethylene, but uh, with the catalyst, that we can change this ethylene, this monomer, the single molecule, to chain-like molecule that is called polymer. So this process is kind of polymerization. So linking together of chain-like molecule, that is polymerization. So most of plastics are made of this polymerization process with catalyst. So it has a lot of deeper areas in this chemical conditioning, but in this class, I just want to say these two elements, like catalyst and polymerization for the chemical conditioning. And mechanical conditioning is first example is work hardening. That means a structural change in metal caused by process of hammering or rolling. So I showed the example, like this is a metal, has grain structure. So by hammering, that change that make harder, or rolling also make the metal harder. So this is hardening. And then also sharpening is a new technique that make harder the surface or the internal structure. Also that remove the stress in the material. So I prepared this video. It shows how sharpening works.
The application of controlled shot peening improves performance, reduces maintenance, and provides a cost-effective solution to premature failure in critical components.
This is a wind turbine, turbine. So this is a heat turbine for like a generator. So lots of heat and then high pressure will be treated in this turbine. So that's why this example shows the sharpening to reinforce its internal structure.
Shot peening is a method of inducing residual compressive stress into the component by bombarding the surface with high-quality spherical media in a controlled operation. The media can be steel, ceramic, or glass, and each piece acts like a tiny peening hammer, producing a small indentation in the surface. The application locally yields the material, inducing beneficial residual compressive stress, the characteristics of which are dependent on the base material and component design. At the same time, unwanted tensile stresses are removed. The proven results from controlled shot peening show a dramatic beneficial effect on both the life and strength of components, welds, and materials, making the material resistant to fatigue, fretting, and stress corrosion cracking. Metal Improvement Company has over 70.
Yeah, so this example shows like premature giving the premature stress to the this object, this to the material. Yeah, that remove the internal structure stress. Also give another another types of internal stress that help to endure so from the another stress. So this kind of vaccine process, we got vaccine to prevent the flu virus. This is the similar things that we put the another stress before getting actual stress that makes the material harder. So this is shot peening.
On the base.
All right, so that's it. This is the conditioning processes. So let's go back to the first. So we described about the heat and mechanical force and chemical actions, or at least three regions: material condition, and then 6 common thermal conditioning practices, and explaining mechanical conditioning about shot peening and hard working. So, all right, thank you.